So you guys should have copied this down already. Once again, just to review, this first rule that you copied down, it's simply subtracting. It's how many x's do you have on top? You have 3 of them. You have 5 on the bottom. So all 3 cancel with 3 of these 5, and you're going to have 2 left over. So your final answer is nothing on top. So you write that as a 1 up on top over x squared. Now, it's kind of pointless to expand and show all this work where there's nothing left up on top, so you put a 1 on top and an x squared on the bottom. You don't have to show your work. Just think about canceling in your head, which is ultimately subtracting, and writing down what's left over in the appropriate spot, either on the numerator or the denominator. So this one right here, showing our work, the 2/8 reduces by 2, and you get a 1 on top and a 4 on the bottom. There's 1x on the bottom that cancels with one of these 3, so you're going to have 2 x's left over up on top. These 5 y's cancel out with these 5 y's. There's no more y's. And also these 7 z's cancel out with 7 of these 9, and you're going to have 2 left over. So your final answer is 1 x squared over 4z to the second. And that's exactly what we have over here, 1x squared over 4z to the second. So you guys already copied this stuff down. Do you understand that first rule? Okay, how about you show me that you understand it by doing this one right here. So when you look at the 3/12, when you look at the 3/12 right here, you could reduce that by 3, and you're going to get a 1 up there and a 4 down here. It's kind of like reducing 3/12, it reduces down to 1/4. Now when you look at your x's, well, you have 3 x's down here and 5 x's up here. So all 3 x's cancel with 3 of these, and you're going to have 2 left over up on top. And with regards to the y's, there's only 1 y up here, and there's y squared. There's 2 y's down here. So this y completely cancels out with one of these, and you have a y left over on the bottom. And of course, if there's 8 z's up on top and 8 z's on the bottom, all the z's cancel out with all the z's. There's nothing left over. So our answer here would be 1 up on top with an x squared over 4 on the bottom with a y. That's your answer for this one. I hope that makes sense. Let's move on. So if we understand that one, let's go back to the rules. We understood the first rule. How about this second one? Do we understand that when you have a negative exponent, you have to move it to the other side? Okay, so right here you have x to the negative 3. You grab it, you circle the whole thing, move it to the other side. I always recommend circling and drawing some arrows. So if there's nothing left up on top, you have to put the 1 up there. And of course, when you move it to the other side, it becomes positive. That's how you end up with 1 over x to the third. On this one, the y to the negative 3 is on the bottom. So the 2x, you're not even going to move it. You're going to leave it there. But the y to the negative 3, you move it up, and it becomes y to the positive 3. And there's simply multiplication between the 2x and the y to the third. So that's why your answer is 2xy to the third. Now you could, if you wanted to, write this answer 2xy to the third over 1, but that's kind of pointless, right? If you don't have anything left over on the bottom, you don't need to put that over 1. You could just leave it like that. But if you don't have anything left over on top, then you have to write the 1. Just to clear things up, like over here, we moved the x to the negative 3 down. There was nothing left up on top. You have to put the 1 up there because there's nothing left up on top. But when there's nothing left on the bottom, you don't have to put the 1 on the bottom. Okay, so do we understand this second rule? Yes, we get it. Okay, so show me that you get it. Now, what do I mean by show me? How about this guy right here? Do it. And make it a little smaller to show some work here. Again, this second rule that we learned today, you take the negative exponents, I like to circle them, and draw some arrows. So I'm moving both of those down to the other side. So this is really going to be like a fraction. And if you move the x to the third down, x to the negative 3, it's going to become x to the positive 3, and z is going to become z to the positive 4 when you move them to the other side. So let me show my final answer here. It's going to be 2y squared, because the 2 and the y squared never moved. They stay up there. And the x to the third, z to the fourth is now at the bottom. X to the third, z to the fourth is now at the bottom. That's your answer for that one. Does that make sense to you guys? Somebody said no. Let's try another one. Same rule, different problem. But this time, I'm going to mesh two of the rules together. The first rule of today, which was canceling, and also the one with negative exponents, which requires you to move to the other side. Okay, so let me make this a little smaller. Hopefully you guys copied it already. So I'm going to apply the first rule that we learned today. If you forgot, here it is. The first rule was all about canceling things out. Whatever you have on top and on the bottom, you could cancel things out, right? So looking at this one, there's x's on top and bottom. This x cancels with that x. It's gone. There are no more x's. But the fun part is there's more than one rule to apply. We're now going to move the negative exponents to the other side. Mario, what's up? So what I'm going to do now is I'm going to take this y to the negative 3. Let me zoom in so you guys can see what I'm doing. I'm going to take this y to the negative 3. I'm going to circle it, and I'm going to move it up right here. And both z's have negative exponents. So I'm going to take this z and move it down there. But I'm going to take this z and move it up here. It's like a football play on a piece of paper. Yes?
Are you going to combine the y's or no?
Let's do one step at a time. Let's do some movement first. Check it out. Movement first. So here's my answer so far. It's going to be a y squared. That y squared up there stayed there. It didn't have a negative exponent, so it's still up there. But this y to the negative 3 is now going to go up right next to it. And it's going to be y to the positive 3 now right next to the y squared. And then the z to the negative 3 is going to go down, and the z to the negative 2 is going to go up. So you're going to have a z to the positive 3 on the bottom and a z to the positive 2 up on top. And once again, you could apply the canceling rule, the subtracting rule with the z's, right? Yes, that's what we're going to do. We're going to use rule 1 from last week. Let me show you that. Rule 1 from last week was that when you're multiplying with the same base, you could add the exponents. 2 plus 3 is 5. So that's what we're going to do with this situation right here, the y squared times y to the third, and that becomes y to the fifth. So my answer is going to be y to the fifth over. Now, how about those z's? I have 2 z's up here and 3 z's down here. I could cancel out both z's with 2 of these 3, which leaves you only 1 z left on the bottom. So your final answer is y to the fifth over z. How does that taste? So I hope we understand this. Of course, we're going to have more practice. Let me get rid of this right here. And for the next rule, the final rule of today was anything to the 0 power equals 1. Well, technically not anything to the 0 power equals 1. If you have 0 to the 0 power and do that on the calculator, it'll say error. It won't work. Okay, so anything else, anything that's not 0 to the 0 power is going to equal 1. Got that, Asad? Yeah. All right, so if we understand that anything to the 0 power equals 1, we should be able to do these guys right here. There's 3 of them. Nice and easy. Try them out. Number 1, what's the answer? 1. Number 2, what's the answer? 1. Number 3, what's the answer? 256. Thank you very much. Why? Because the only thing that has the power of 0 is x. X has a power of 0. So that's really 256 times 1, which is equal to 256. Now, it would be a different story if you had 256x to the 0 power with the parenthesis around the whole thing. Then, yeah, that equals 1. But in this case that you're seeing right here, it's 256 times x to the 0. That's really 256 times 1. So your answer is 256. Now, it really becomes fun when you start meshing all the rules together. All right, so here's an example where we're going to mesh several rules together. How about you guys try copying that one down? So there's a bunch of rules there's about 6 rules, 7 if you want to count them as 7, but as long as you are applying a certain rule and you're doing it correctly, you're going to get to the same answer. There is no rule that you have to follow before anything else. But for example, you could decide to distribute the 2 to each and every single exponent term inside the parenthesis. You could, but I wouldn't do that. I would start with the inside and see what you could do on the inside, and then worry about the power of 2 on the outside later. So I would start with the fraction 3/9. 3/9 reduces down to 1/3. Yay? Yay. Okay. Now, what about those negative exponents? What are you supposed to do with the negative exponents? You got to grab them and move them, and I like to circle. So I want to zoom in even further. I want to circle this x to the -3, and I want to put it right on the right side of the x squared. The x squared doesn't move. And then I want to take this y to the -2, and I want to move it down over here. But you know what? I could also just look at that thing and know what z to the 0 is. What's z to the 0? That's just 1. So I could just take that z to the 0 right now and just scratch it out. Now I could put a times 1 right there, but what's the point of that? 3 times 1 is just 3. It's not going to change anything. So I'm not even going to put the times 1. I'm just going to scratch it out. Anything to the 0 power when it's in a large expression like this, you could just scratch it out because we know it's really a 1. Anyway, let's move all that stuff around, and we're going to have the parentheses left over. We're going to have a 1 on top, a 3 on the bottom. We're going to have the x squared that didn't move up on top, and we're going to have the new x to the 3rd that we actually moved up. And on the bottom, we're going to have the y squared that moved down, that became +2. And on the outside, we still have the power of 2. Are you with me? Okay. So now let's take a look at the inside and continue. Let's apply a different rule. Rule 1 that we learned last week, x to the 2nd times x to the 3rd. What is that? Okay, so on top, I want to have x to the 5th, and on the bottom, I have 3y squared. And now at the very end, I want to apply that rule that we learned last week. They have an exponent on the outside of parentheses. Distribute that exponent to each of the inside exponents. So power to a power, you multiply. That's going to end up being x to the what? 10th. Okay, so you know what? Let me make that smaller. Move this up. So I'm going to have x to the 10th over what? It's not 6. Right, it's 3 squared, which is going to become 9, y to the 4th. Power to a power, you multiply, but 3 to the 2nd power is actually 9. So you really have x to the 10th over 9, y to the 4th. There's your final answer. Yes?
Wouldn't you also distribute it with to the 10th power?
Okay, so good question. You have a 1 right here. Don't you distribute the 2 to the 1? Well, think about it. It's not 1 times 2. It's actually 2 to the power of 1. So that's 1 to the 2nd power, which is still 1. So whenever you have a 1, you don't have to write it. You could just, that's why I didn't even write the 1 right here. But even if you were to write the 1 and distribute the 2nd power onto the 1, 1 to the 2nd power is still 1. So you can put a 1 right there if you want. But that's still your answer.